Okay, let's dive in. Today we're uh, connecting some dots you might not expect.
Yeah, we're looking at college level calculus differentiation integration and how it links up with, well, forest resources technology.
Right. Specifically, how nutrients leave the soil in forests.
Exactly. Our source material really zeroes in on that connection. It shows how these, core math concepts are actual tools for understanding that process. Soil nutrient depletion.
And the source specifically flags this as really relevant if you're like right in the middle of studying differentiation and integration in your math course.
Mhm. It clicks there.
So our goal for you today, let's try to unpack why thinking about the rate of nutrient change matters in forestry.
And how calculus, specifically differentiation, gives us the language to talk about that rate, to, analyze it properly.
Makes sense, because soil nutrients in a forest, they aren't just static, are they? Things are always changing them.
Constantly. Rainfall, how much the trees take up, maybe logging, all sorts
Mhm.
of things affect the levels.
So a forester needs to know more than just how much is there now.
Right. They need to know how it's changing. Is it dropping fast, slowly? Is that rate itself changing, speeding up?
Okay, and that's the perfect entry point for differentiation.
Precisely.
Forget just abstract tangent lines for a second. Think of it as a tool, like a speedometer, for change.
Yeah, the instantaneous rate of change.
So if you have some function, some math equation describing nutrient levels over time,
Its derivative tells you exactly how fast those nutrients are increasing or, more likely, decreasing at any specific moment.
okay, so you get the speed.
Exactly. And the source points out that analyzing the properties of that derivative, that rate function, gives you real insights.
Like what? Give me an example.
Well, maybe understanding the maximum rate of nutrient loss right after, say, a big storm or a harvest.
Ah, okay. If it's losing nutrients really fast, then that signals maybe you need erosion control, like right away.
Or you could compare how fast different tree species suck up nutrients, their uptake rate.
So it's not just about the total amount gone, but the speed it disappears tells you what needs doing now.
That's a big part of it. But the rate alone isn't the full story.
Right, you need the other half of that calculus chapter, integration.
Yes, and the source highlights its importance too.
Okay, so if differentiation gives us the speed at one point in time,
Integration lets you figure out the total effect, the accumulation over a whole period of time.
right, you're adding up all those little instantaneous changes.
Exactly. So you integrate that rate function, the derivative, over, say, a growing season, or maybe 20 years.
And that gives you the total change in nutrients during that entire time.
Mm-hmm. The net loss or gain?
And that's huge for planning, right? Long-term stuff.
Definitely. If you know the total nitrogen loss over 2 decades, you can predict if the soil will support the next generation of trees.
Or if you need to think about adding fertilizer down the line, you're tracking the cumulative hit.
So you see how they work together. Differentiation for the immediate dynamics,
Yeah.
the speed.
And integration for the big picture, the total change over time.
Yeah, the source shows that using both lets foresters model nutrient cycles much better, predict future soil health.
And just make smarter decisions for keeping forests sustainable.
It really grounds the calculus, takes it off the page, and puts it into, well, the soil.
It answers that classic student question, when am I ever going to use this? Here's a very tangible answer.
And recognizing that connection, like the source suggests, can actually make learning differentiation and integration feel more, I don't know, meaningful. You see the utility.
Absolutely. Okay, so wrapping up. Differentiation measures the rate of change, like nutrient depletion speed. Integration measures the total change over time, like total nutrient loss.
That's the core connection.
So here's something to think about. If these calculus tools can help us understand the speed and total impact of nutrient changes in a forest,
Hmm.
what other environmental changes could we analyze this way? Think about rates and cumulative effects. Climate variables. Wildlife populations, maybe?
That's a great question. It's a powerful way of looking at change in almost any system, really.